this demo. Oh, it's pretty good. Quality game as well. Hello and welcome to the Retro Robin Show with me, Wayne Retro Robin. Slightly different format to the show today. Just thought I'd tell you a few little tricks to the trade that you might be able to use. Ever wondered what games like Anteriord, Roller Coaster, think of a few other, Bostacan have all got in common? No? Okay, well I'll tell you. If you know anything about the memory map and the way that the memory is stored in its little blocks, you've got your section of the data file is between 16384, can't believe I'm having to read this, I should know this off by heart, shouldn't I? Up to 22528, and then of course you've got your attribute section. And then you've got your printer buffer and your system variable memory, and of course usually basic starts 23756, which I used to use as the poke for line 0. If you've got to say put 10, we'll show you, shall we? It's a well-known poke. Let's go into 48k basic. Let's type 10. Let's just enlarge the screen so it's what you can do. I'm going to come to it. It's all got a point, don't worry, it's all got a good point. 10, let's use the rent statement. 10 retro robins. Right, you can see that clearly up there. Now if you poke, we'll change that to a 0, or up until virtually up to a 256, I think it is, or but you go beyond that. So if let's say poke 23756 comma 255, and that's probably as high as you can go without getting into a bit of code itself. So you can change that using that poke. Now that's where the basic starts, where you can store basic files, but obviously if your program's going to be all code, you're just going to wipe over that first section of basic because you're going to write over it. So what coders do, a little trick to save memory, and they're all involved on each one of these games, and there's a number of games that do this, is when they're actually writing a program, they decide where, it's almost like storyboarding in their own head, where they're going to put certain sections of data. And obviously they're going to start by thinking, how can we make as much space available as possible? So what games like Roller Coaster, Anteriord, Glass, and Bostacan, and one or two others all have in common is the last part of the game where it's loading from a tape file or even from a Z80 file or whatever. They load the display files so as it's permanently on the display, and then they only write the code in the square boxes. What do I mean by that? Well, let me show you. First of all, let's select a game, and this is going to be more of an educational thing today. Start with one of my favourite games, Anteriord. Right, now can you see that blue dashboard thing there? Well, all the graphics there are stored on the screen, right? The top half of the screen is refreshed. Now if I was to be able to put a clear statement in that, wipe that off, that bottom part of the display file would be gone, wouldn't come back, but there would be colours there as they change the attribute colours in certain blocks of that area. But by doing that, they've sort of saved a couple of K worth of memory, if you know what I mean. So they've maximised the space. They start from the outset of doing this. It's like Bostacan and Anteriord, and you know the surround on Anteriord, and of course Bostacan, the surround. That's also loaded at the last minute of the game. So once it's throwaway data. It's there, but it stays there. It doesn't need to be kept anywhere else. So it's kept in the display file area permanently, and by doing that you allow a little bit more space for you to fit a little bit more code in. It's clever stuff. But, you know, if I was to say, let's, for instance, let me just put a poke in, shall we? Now what we're going to do is we're going to poke in the attributes area. So let's poke at 232. Oh, sorry, I need to press P for poke. Right, 232, and if you work it out right, so we say 90. No, we'll say 90. Yeah, 90. And we'll. It's you've got 1. So let's put 0. 0, and obviously 1 is blue. Let's say, should we change the colour of that, shall we, to 3, right? Enter, and now we just have to break and return, and you can see that that's changed colour. So let's try that again. So let's poke again. 2, 3, 2, and of course we want to go a couple higher, because what I'm trying to do is find out where the little black circle is. You'll see something in a minute. 2, 3, 2, got to go down to, so if that's 90, let me just quickly work this out for you. 2, 3, 2, I'd say that's 30, no, 65, and that is also 1, so we know we've got a blue section. So let's put that as a different colour. Let's go 4, okay? So 0, 0, 4, which as you know is green. 2, 3, 2, 6, 6, 0, 0, 5, 2, 3, 2, and so we say 6, 7, and that's 0, 0, 1, so it's going to be 0, 0, 7. Okay, now we break. Whoops. Right, now as we return, you can see a little dot of white there where I've hit there. I've changed the colour. Now if I can work out roughly where these black dots are, you will see what is hidden behind there. The graphics is hidden behind there for the, you know, and then also on the so we just write the data into the little bits of that area. But there you've saved all that, and a few games that I'm going to go through with examples of that are, there's this one, Anteriord, and we'll go for a more extreme example. This one uses a lot more screen data to let me show you what I mean. I've got to go back a few files actually. We'll go for 2, shall we? Go for 2. 2 of my favourites as well. Let's go for glass. Now the whole top edge, which, let me point it out, I need to stick that on, the whole edge round all the way there, all the way across and down, and then that section across the bottom is graphical data stored in the display file area just before the attributes begin. So let me just poke it, I'll prove it to you, because it'll never change because it's never refreshed. The only parts that are refreshed are the colours. So let's say, let's start from the square one, shall we? What we want to poke it in the attribute. So 22529, and it says 255. 223. I've put, haven't I? So I've got to delete that. Sorry. Right. So we're going to go to. Right. We've got to go to 225 and 29. Right, and obviously Magenta, and it's a Magenta colour in the corner. But we're going to change that now to a number 7. So we're going to go for white. Okay, and we'll do another one exactly the same. 22530, James Bond again, and then 22531 007, and then we'll break and we'll return into the main program. See how those top pixels have gone white? Now let's So what I've also done, if you look at the bottom section here, I've blacked that out, right? And what I'm going to try and see now, I've also changed a little bit of graphical data there, is the part up there will refresh and the part down there should stay black. Well, we'll try now, shall we? So let's return to the game. And as you can see, that has stayed black and that hasn't refreshed, but it will refresh because that part is actually stored in the game itself. So by starting before they actually put the program in, and as you can see, it's refreshed at the top, but it hasn't refreshed at the bottom, look, as I said it would. By starting before you write your code and your program in this, defining ways to, I'm going to die in a minute, to find ways to save any dateable usable space if you like. That may not refresh. The colours should refresh, but yeah, that's going to stay there permanently now. Those 3 squares that I've blacked out at the bottom as well, that's going to be there throughout the game, because that data is now lost, if you know what I mean, because it was loaded at the end of the game separately, or you like at the start. So what other games do that sort of thing? Well, let's show you. And on this one we're going to load a file, and we're going to choose a file to load, which will show you now. Right, yeah, we'll do the Sacred Armor of Anteriord, yeah. Now what I'll do is I'll break this game, but while we're loading it, you can hear the data loading there. And it may not show you the screen string. That's just a loading program, so as you can load this bit headless, and you can obviously this carries on using the data where you basically, so it loads the screen string and then carries on loading through. But we ain't got to worry about that, because all you're going to see on the loading screen is the armour of Anteriord itself. But the data, saving graphical data, is in the game. The main code is kept at the end of the game, but on the screen itself, you'll see in a minute once we get there. That part at the bottom stays there constantly, right? So I could let this load, but I'm not going to. What I'm going to do now is I'm going to keep that on the screen, and I'm going to poke. Stop the file. We don't hear that now. So let's say poke. See if we can get, you see those 3 little round squares there? If we can work out roughly where they are, which should be in the attributes area, we can reveal what's hidden behind them. And by only changing the colour of the attributes in that square, there is graphics behind them. So I'll show you. So poke at, now I need to take 21 off, and so basically I'll take 21 off the final attribute. So 21 and 22, so 232 3 0, and it's got 001. So if we put 0 0 0 and 232 and 28, let's put 0 0 7 232 2 7, and that's what we're looking for. So if we put 0 0 7 there, and 232 2 6, and that's 1, so we'll put 0 0 7, you should see there. That's what we want to see. If you look just there, there's a little nut head, if you like, but that's constantly there, and all I've done is I've blacked the other part out, but the graphics are still there, and that part stays, the graphic, shall we say, probably talking about it real badly, but that part stays there permanently throughout the game, and that way you don't need to store the code for that graphical data anywhere else for it to refresh on the screen. All they change is they change the colour of that particular square to a yellow, as it happens, once you collect that particular item in this game. And there's a few games that do that, and it's pretty good. It's a clever idea of saving space. Now, have you ever wanted to save your own Hyperload game but never understood the code on how to do that? Well, before I learned a little bit on machine code and Z80 assembly language, which is as tough as nails, and I'm not brilliant at it, not as good as I'd like to be. That's fine. You obviously always think you're better than you actually are, and then when you see other people's work you think, goodness me, I wish I could do that. So I've got a little trick for that. I'm just going to pause this for a second while we reset the screen. I'm going to break that because I don't want that. Right. Okay, so what we're going to do, we was talking about Hyperload, and there was a game that I found called Critical Mass. Fortunately I can't find the right tap file for that, but there was a code section, and if you was to load the code section, which started at 65036, which was pretty much, but if you was to type let L equal USR 653006, if I remember rightly, you could effectively save or load your games by putting that before the save speech, whatever speech, in Hyperload, by nicking the Hyperload from Critical Mass. So yeah, that's some of the secrets that they used for maximising the amount of code you could put into one program by finding clever ways to use the unneutralized areas of the system's memory. In fact, the display file, if they didn't need to use it all, was a good place to leave a lot of graphical data, because if you were to keep that in the area where you want to keep the rest of your code, then you were using up more than you needed to, because obviously if you didn't need to refresh the screen, then that was a good place to leave graphical data there. Obviously there are other ways that they saved space, was not to load the game entirely in one go. For instance, if you had a 48K Spectrum and you was playing R-Type, unless you had the 1 to 8K Spectrum, which used to load each section in a different bank of your 128K, by switching through various different banks on the chip, it was able to save more data and just change to levels that way. The other way that you'd have to would load it in sections, so you'd have to say, if you got through part 1, you'd then have to load part 2, and if you got through part 2, you'd have to load part 3, which was great for games like R-Type, where you might only have to load a total of 8 sections. But when you got something like Gauntlet, and there was like loads and loads and loads of sections, it became a bit annoying, especially when you had to go back to the beginning and start all over again, so you'd have to rewind the tape on side B all the way back. But that was another way of them saving code. Anyway, that's all enough from me, Retro Robbins. I hope you enjoyed this little tutorial type show on secrets of maximising the space on your Spectrum. And if you did, please remember to like, subscribe and share. And obviously I'll be doing some more of my Crash Magazine re-reviews soon. But for me, Wayne Retro Robbins, you have a good working week or weekend, or depending on whenever you watch the show. Thank you for watching, take care, and bye for now.